And we're live. Greetings, everyone. The Crazy Cat Ladies are proud to present week 8 of the Safe Spring Saturday Seminar Series. One of our team's first memories of First Tech Challenge was watching today's guest, Team 4717, the Mechromancers, play at Minute Maid Stadium in the Houston World Championships.
This year, they are the winners of the Collins Aerospace Innovative Award at the Florida State Championship. Here to cast a spell on you and tell us about innovation that excites, we welcome the Mechromancers.
Hello.
All right, guys. So today we're going to be talking about innovation that excites. We're going to basically be going over how to really create innovative robots throughout the season. So we are Team 4717, as they mentioned earlier. We are from Haggerty High School in Oviedo, Florida. So this was our team this past season, the 2019-2020 season. We had 14 members. So Ben is our hardware lead, and I am the communications lead. My name is Jolie. So a little bit about us. Our team was established in 2010. We were originally an all-girls team called Estro Genius, but as we've developed, we've become a co-ed team called the Mechromancers. We are entering our 10th season this coming season. Again, we're part of the Haggerty High School Robotics program. So we have 2 FTC teams in our program, 2 VEX teams, an FLL Challenge team, 2 FLL Explore teams, an FLL Discovery class, and a Roboboat team. So just a little bit of our award history. So this past year, as the Crazy Cat Ladies mentioned, we had First Innovate at the state championship. And just over the past couple years, a lot of our awards have been somewhat robot-centric or related to them in some way. So we're just going to go a little bit over the Innovate Award itself. So directly from the game manual, the Collins Aerospace Innovate Award celebrates a team that thinks outside the box. So when you're designing a robot, you really want to make sure that it's not something that everyone else is doing. It has the ingenuity, creativity, and inventiveness to make their designs come to life. This judged award is given to the team that has the most innovative and creative robot design solution to any specific component in the First Tech Challenge game. Elements of this award include elegant design, robustness, and out-of-the-box thinking related to design. This award may address the design of the whole robot or a sub-assembly attached to the robot. The creative component must work consistently, but a robot does not have to work all the time during matches to be considered for this award. Team's engineering notebook must include journal entries to show the design of the component or components, and the team's robot must be eligible for this award. Entries must describe how the team arrived at their solution. So I just wanted to highlight, it doesn't always have to work, whatever component you've designed or your whole robot, however you innovate. So the award requirements, this is directly from First. The team has to show gracious professionalism throughout the event that they're at. You have to submit an engineering notebook that includes engineering content, your overall team journey, how you've created your robot from day one. Your robot or sub-assembly must be creative and unique. So it's got to be something that you don't see very often during a competition. It has to be stable, robust, and work reliably. Just because it's unique, if it doesn't do very well, you know, it has to be efficient and effective to the challenge. And the design has to be consistent with your plan and strategy. So just looking at our past couple robots over the past couple years, this was our 2017-2018 robot. His name was Buzz. He was a little different. A lot of teams that year focused on a dump truck type of robot where they would intake blocks and then turn around and just shove them directly into the cryptograph. That was the scoring for that season. And so we did a little differently. We used 2 arms and then just pulled them over the robot, which you'll see in a video on another slide. So 2 seasons ago, 2018-2019, our Rover Ruckus robot was Bullseye. And the main innovative feature you'll see here is that we took a divot out of our wheels and we had 2 big wheels instead of having like a 4 to 6 wheel robot made like a tank drive type robot. And what this allowed us to do is climb over ledge in the corner of the field. And then last year, our robot for Skystone, his name was Roombob, and he focused on, instead of stacking Skystones from the top, as many other teams did, we stacked from the bottom to maintain a consistent style. So just little videos real quick to just show some of the innovative things we've done over the past couple years. This was our jewel hitter in the 2017-18 season. And it relied on using actually a rubber band and stored energy, so that we didn't have to have another fully automated mechanism. We didn't have to have another motor or anything. It was all done on its own. We could just use a servo to release something, and you can see it uses rubber bands to actually pull the point around. And then again, from that season, you can just see exactly how we lift and score instead of doing a dump truck method. So that's just a little bit there. You can see how we used sliding instead of turning and stacking. So again, 2 seasons ago, you're just going to see a little bit of the innovations that we were going for when designing that robot. So again, the arms going over, so we didn't have to worry about turning around. And then you'll see here again, you can just see we used arms to line up specifically where we needed to go. So our robot never really had to move; it just had to go back and forth. And you can see again the arms. We had them automated so that they could either move on their own, or you could just press buttons and they would move together. So our relic recovery robot, wrong one. Rover Ruckus robot, you can see that we chose to create an intake on an arm that could actually flip up and down. So those arms were actually meant to stabilize the 2 big wheels that we have on either side of the robot. And you can see we wanted to focus on launching. A lot of other teams used a scoop and dump method. And that year, you were allowed to launch as long as you were touching within the lander. You had to be underneath of it somewhat. So we focused on that. And when we wanted to lift ourselves, we actually focused on using the entire robot to curl up instead of like an elevator mechanism to just go straight. And then this past season was our Skystone robot. And you can see right here, we wanted to try to use a conveyor belt for our intake. And that just allowed us to really, you can see right there, slide everything directly out. This was our original mechanism, was a shoving type mechanism, but it was having some issues, so we transitioned into that conveyor belt that you saw above. And our main goal with this robot was to really stack from the bottom, which you didn't see a lot of times. A lot of teams went for stacking from the top, but what this allowed us to do is we never had a maximum stack limit. We could continue to stack until the time was up. We had no hardware maximum. So the innovation process, talk about that. Ben, you're muted. All right, I'm going to let Ben fix his muting situation.
Oh, my bad. I thought I was unmuted. So every idea for our robot starts with the initial brainstorm at the start of the season. So as soon as we get the game, we look at the game, see what designs would work, and then we try to sketch it out. These are 2 of our sketches for the past season Skystone. So this is part of our intake that we saw, and it's free and it's easy to sketch out a design, and it helps communicate to everyone. But we try to see how the game can be made more interesting and provide more opportunities. So it makes the challenge more fun, and to choose a design that's going to be somewhat challenging to you, but being enjoyable leaves a lot of room for learning opportunities while still being innovative. Great, next slide, Julie.
All right, so cycle of innovation is just something, you'll see a lot of cycles of engineering. This is just something we like to go through every season. So we start off with the first title of our cycle is brainstorming. So what is the challenge? How can we solve it? Where are we going with this challenge? So last year, the challenge was you had to stack blocks. So how were we going to do that? We could either stack from the top or stack from the bottom. So next you go to prototyping. How can you make the idea into something physical, something that you can interact with and then work on from there? What is the best option for later designing? And the great thing about prototyping is that you can make a whole bunch of stuff really, really quickly and test each one and figure out what you think is going to be the best from there. And then CADing. How can you make it manufacturable? You know, you want to make sure that the robot is spaced out properly. You have enough room for all the components that you want to have. Then you have testing. So you want to make sure that everything works properly. You want to make sure that it works well. You know, is it effective in the challenge? And then you move on to improving. So how can you make it more effective? Does it work? What doesn't work? And how can you make it better?
All right, so the first step is brainstorming. So there are no dumb ideas. Every idea can lead to other ideas that may not have been thought of, even if the first idea wasn't even communicated. You also got to take the time to research and sketch out the designs. Any of the designs that come to mind, if you sketch them out, it'll it'll help it be a more realized concept, even if it seems it doesn't work. It'd help you explore how the robot might function by using the part, or how it could like fit into the robot as a whole. And pushing the game itself is where it's conducive to innovation. So coming up with a unique way to play the game and how each game works and which way you can solve them. But don't think of every idea as having to reinvent the wheel. Look at previous designs from both your team, other teams, including not just FTC. You can see here 148 Robo Wranglers in the Recycle Rush season was an inspiration for our Skystone robot because their game was stacking recycle bins on top of each other. So, but they stacked them underneath. So we took that idea and then translated that into an FTC and made it more innovative towards our robot.
Yeah, so just to emphasize, you know, when you're doing something with, you know, an innovative idea that you have, it's always great to really research things that have come before you, just to make sure that, you know, you're not spending too much time trying to come up with something. If you see something that works, figure out how you can improve upon it.
And then after you brainstorm and kind of like thought of a couple ideas, prototyping is really, really important. It's basically pre-testing before you actually have to spend the time to make it and manufacture it. So you can use anything that you can get your hands on: cardboard, C-channel, Legos. I've heard from other teams. You see in this picture that it's not a very elegant design and it's not really like properly made, but it's not about perfecting anything. The main focus is get some improvements that might have come out after you've made it instead of spending all that time to make the final product, but then having to realize you have to change it. You have to do this like quickly. Don't waste time on an idea that might be flawed because you might have an idea that seems like it could work, but when you prototype, it it won't work at all, and then you wouldn't want to waste the time and resources on finishing the final product. And you want to flesh out those big improvements that can be made, like having oh, this wheel can't be there because it'll mesh with a different gear. That would be it's easy to come out in prototyping, but it's not really costly in time or money if you build the whole thing.
Yeah, just to emphasize, I mean, when you CAD something, you can CAD anything you want, any shape you want. If you have the materials to be able to manufacture it yourself, you can do anything. And the great thing about prototyping is that it forces you to work with somewhat what you have and to really figure something out that's realistic instead of daydreaming about everything and just CADing the whole day away. So moving
On
on to our CAD.
on the topic of CADing, we use GitHub to share all of our files and resources. And the actual software we use is called PTC Creo. PTC Creo is good because it allows you to create skeletons, which is what the bottom picture is. And it allows you to like build stuff off of a simple design. So you could take your sketch that you made during the brainstorming process, put it into CAD, and then build stuff off of it. And another good thing about CAD is you can space out your mechanisms. So if you were just trying to build it on the fly, you might run into a problem of, oh, this mechanism doesn't have enough space to put next to this other mechanism. But in CAD, you can see that and you can make changes effectively. And it doesn't take a lot of time to change something in the CAD, but it would take a lot of time and resources to change something on the actual robot. So CAD can let you make quick changes and see how it could affect reliability without wasting time, manufacturing. So after you've CAD'd and manufactured everything, obviously you have to test. So we like to keep a log, just like in science class. If you don't write it down, it never happened. Usually this log will be the engineering notebook, which also we'll talk later about that, which makes it easier for the notebook to happen. And it's your idea is never completely finished the first build. The more you test, the more reliable it will be. But don't give up on an idea just because it doesn't work once. Sometimes just a few small tweaks will just work, and it'll make it easier to to work in competition, but without abandoning the idea all in all. More innovative ideas like our previous robots come with a lot of testing because you can't really look at other people's and see, oh, what do they do? How do I fix it? You really have to come up with yourself, and a lot of the ideas won't work, but you just have to keep testing and testing. Sometimes, sometimes assemblies will not work at your first competition. One of our ideas in the relic recovery season, it didn't work a single time up until the league championship. But then once it worked, we got it down really reliable and it was faster than a lot of the other mechanisms. But we had to take the time to improve it and test it a lot of times. But know when to walk away from an idea because if your idea is flawed enough that you can't fix it with a few small tweaks, it's fine. It's totally fine. Just back away from it and then try a different angle. One of our ideas in the Rover Rocket season, we backed down from it quickly because we realized that the design from the start wouldn't work, and it's not valuable to spend all that time trying to get it to work, but when it won't work, testing takes a lot of time, but it leads to more effective and more reliable like mechanisms.
Yeah, and it's really important if you have an idea that you really love a lot and it's just not working no matter what you try to do. Sometimes you just have to walk away, look at other ideas and really decide, what is going to be more effective, what is going to help us complete this challenge. Because sometimes the most innovative idea is not going to be the most effective for the challenge, and you do want to make sure that while you're designing and while you're testing, you're doing something that's actually consistent and works well for the actual challenge that you're trying to complete with that mechanism.
So after you've tested a lot, then you have to improve. So improving is where the innovative idea like actually takes shape. So you put everything you've learned from testing into improving your design. But if it doesn't work well before and it doesn't work consistently, this is when you make it consistent and make it work well, or as well as it can in the time constraint. Um, the improving restarts the whole cycle. It's part of that whole engineering process. After you improve it, then you go back to brainstorming how to make it better, more prototype improvements, fix the CAD, and test, and test, and test, and test. Because if you have enough data, and you know how the mechanism works with its previous state, you'll know easier how to change it and how to make it more reliable. Um, you have to, in the improvement step, you have to truly decide if the assembly is going to be efficient to the robot. Consistency is very, very important in the competition because you may have a mechanism that works for a match, but then the other 5 matches it won't work, and then that's wasting too much time on something that just doesn't give you a net profit, and that can take a lot of time and a lot of resources. So some of the ideas that we've had haven't been consistent, and that's really put a detriment on us, but the ideas that have been consistent obviously are net us more success in the competitions, such as the rover no not the relic recovery season and the skystone season. If you can't improve it and make it work, it's okay to just go back to the drawing board and restart on that specific idea. Spending a lot of time to have an idea not work is it doesn't feel good as well because you've put a lot of time into it, but it just doesn't work. But learning from how that assembly might not work could help the next one, work a lot better.
All right, so it's really important when you are making your innovative robot, you need to focus on your notebook as well. So as you're designing, you take pictures of each iteration of your subassembly and your whole robot. Each step as you're going through, take a picture because that picture is going to speak 1,000 words in your notebook, and to any other team members who may not have been there, if they miss a change, that picture can help show exactly what you changed, how you changed it, all your testing data. You want that in your notebook because you can go back and you can look and you can see, okay, this didn't work because of this. This didn't work because of this. Oh, it worked this time because we did this. All of your testing data. You need to make sure whenever you make a log, you write down what you're doing, why you're doing it, how you're doing it. You need to really go through and be thorough. That way you can really learn from everything that you're doing. If you don't log it, you can't learn from it. So really make sure you have any charts, images. You can see down in the bottom left, that picture is, an analysis of the heat coming from the friction of our conveyor belt moving. And that was really important so we could figure out how to minimize that heat. Again, write up the why, not just the what of your changes, because just writing, oh, hey, we added another screw to it. Why? Was it because it was too loose? What made you change something on there? If you don't write the why, you're bound to just repeat your mistakes again. And again, quality of words over quantity of words. If you're not getting anywhere with the words that you're writing down, you're not going to understand what you're trying to say, even if it's 3 paragraphs long versus 1 or 2 sentences that really gets all the data across. And your engineering section should cover the entire journey through the season of your robot. So from day 1 of 4 wheels and C channel all the way to the end of, high scoring at your league championship, all the way through, you really want to make sure you get from point A to point B to the finish line, everything that you've written. Every up and down, every failure, document your failures, okay? These are really important because you need to understand why did it fail? How can I make sure that it doesn't fail again? Learn from your failures. Woody Flowers told us that all the time, guys. Learn. Show why you changed what you did. Always the why when you're writing for your notebook. So just some quick tips when you start your brainstorming. Read the game manual because you can have an amazing idea. It can, complete everything you've ever dreamed of. But if you don't know what the rules are, you could be violating something, and that's just going to cause you issues later on when you have to fix that idea to try to meet the rules of the game manual. Not every single part of your robot has to be entirely unique and innovative. Innovative robots, like the award itself said, just something on your robot that is unique and innovative and completes something efficiently and effectively. You don't have to have your entire robot be innovative. In fact, sometimes it's even better to not do that. As long as it's reliable, put it on there. You can have parts that are similar to other teams. A lot of teams come up with the same ideas. That's okay. Watch YouTube videos of other teams designing. But whatever you do, build off of their ideas. If you see something that, somebody else has built and you want to understand how they built it, ask them. Ask them, how did you design that? What did you come up with? It's okay to walk away from an idea that's not working. We said this earlier, but really, if you have something that's just taken up way too much time and it's still not working, sometimes you just have to walk away, get a clear head, try something else. You either figure out whatever was causing the issue when you walk away, or you determine that something else is more efficient and more effective in your design. And CADing. I cannot stress enough how great it is to CAD something before you build it. You can see any issues that might be there before you buy all the parts and try to build it all yourself. And when you CAD, you can really make sure that you've spaced out enough area for each mechanism that you're putting on there. At the beginning of the year, you might just put some boxes and say, all right, 20% of the robot needs to be set aside for this mechanism. We don't know what it's going to look like yet, but we know that it's going to need about this much space. Again, sketch all your ideas out, log everything, from the little tiny idea in your brain all the way to actually being on the robot. It's a great idea to have all of your stuff written out somewhere. That way you can really go back and see your view process and how you were deciding to get all of this done. And again, why? Why did you change it? What was the reason behind everything you're doing in this robot? It's really important to understand why you're changing something, because if you're just changing something to change, you're not learning from it. And that's what's really important about FTC is while you're designing, while you're making something innovative, you really want to learn from it and take it into the real world later and just really focus on the education behind everything you're doing. So that's all we have. So if anybody has any questions, feel free to contact us as well.
Yeah, if you don't mind, we'd love to ask you a couple questions.
Of course.
It looks like you use a lot of wood in your designs. What tools do you recommend for working with wood, and any other tips on custom fabrication?
Our wood aesthetic comes from we laser cut it. So our mentor, Mr. Harper, he works at the UCF Innovation Lab. So we get access to laser cutters and all the like custom machines that we can use. So we personally use laser cutters. Those they work really well, and they're really cheap to like prototype with. But you can use CNCs as well. They're good for working with wood and metal and making custom parts. A tip for using wood is you can use a lot of it because it's cheap. It's semi-durable, so your designs will hold up if you make them like strong enough. And it's very easy to prototype because it takes like 5 minutes to cut a plate out on the laser cutter and attach to your robot. And if it works, it works. If it doesn't, it doesn't. And it all comes from the CAD because you can quickly CAD it out a change that you may need to make, and then just put it on the robot. And if it works, cool. And then otherwise, you can just go back to designing.
If you don't have access to a woodcutter or CNC mill or any of those things, if you live close to a university, it might be great to reach out to someone who works in the innovation lab there, see if you can get access to their stuff, or even if you want to write an email to a sponsor, maybe they'll be willing to give you money to purchase your own. We do have a smaller woodcutter that we have up in our room at our school. That doesn't cut as big items, of course, because it's not university level, but it does let us cut out stuff somewhat quickly while we're sitting there in the room working. So if that's something you're looking into, if you want to start working with wood, really start reaching out to some sponsors or people near you to see if you can get access to some of those resources.
When planning your designs, what do you consider the most? Strength, efficiency, how many points can be scored? What do you guys look for?
Probably efficiency as well as reliability, because if something that can score points fast is good to work with alliance partners, even though it might not score like a big lump sum of points, and it'll score a lot quickly, and it'll leave a lot of time for the rest of the match that you can score points or help your teammate. But reliability is really important because if it doesn't work most of the matches, you won't get that many points.
Yeah, so really efficiency, speed, and reliability. We actually go through and we make charts to figure out when we're thinking through an idea. We'll say, all right, on a scale from 1 to 10, how reliable do we think this idea is going to be? How fast do we think it's going to be? And that's where that prototyping comes in. If we could just make something basic, like for example, a launcher, if we wanted to make like a catapult, we could see, all right, how fast is this catapult going to be versus 2 flywheels that are launching a baseball? So really, main focuses are going to be efficiency, speed, and durability. Make sure that it's actually going to function and stay on the robot.
You've also pointed out how important it is to keep a detailed engineering notebook. Does your whole team work on it?
Yes, our whole team works on the engineering notebook. Everybody has a part somewhere to help. We do have one person that oversees making sure that it gets formatted properly, but everybody does contribute writing something. If you've done something on the robot, make sure you've logged whatever you've done for the day and make sure it's put in there.
How does your team work efficiently and effectively in meetings, and how do you up your work?
Our team splits into committees. So there's a hardware committee, a software committee, a notebook committee, all those different committees who have like specialized work. So the hardware committee will just work on the robot while like in parallel to the software committee, working on their program and getting time to test it, as well as the notebook people. I mean, granted, it's everyone who's doing the notebook, but the notebook committee will like set up the notebook so it's easier for people to just go in and add their entries. But we have a meeting each time we meet. We just update everyone on what's going on and how we can be most effective, and that streamlines pretty much most of our work.
Yeah, good communication is always really important, whether you use Slack or Band or Discord, however you coordinate that. We actually have different channels for each committee to talk through, and they're all public. So everyone can go through and read exactly what's going on, and they can mute whatever they don't want to be getting constant notifications for. And we really do divide our team, like Ben said, into each committee, but everyone is welcome to work on whatever they are interested in. So if people are interested in hardware and software, they're welcome to bounce back and forth, whatever, do whatever the team needs at the time.
Thank you for all of your knowledge. The last question is very unofficial. Do you guys have any guesses on next year's game?
Shooting game. I think it's been a while since the shooting game, as well as sports games in the past, and FRC have been shooting games, as well as shooting games in FTC are generally like on the sporty side. So I think it'll be a shooting game.
When I watched the teaser that they released, I think a month or two ago, I was looking through, and they had monkey bars, and so I'm hoping that there's hanging in there, because that's always something that's really fun to figure out, how to make sure your robot hangs. So I think there might be something with hanging, and I'm hoping they're bringing shooting back around, because Velocity Vortex was really fun.
All right, that concludes SSSSS for today. Thank you so much, Mechromancers, for such an excellent presentation. Your robot designs are outstanding, and we've learned so much today.
Thank you.
Thank you.
Thanks again, Julie and Ben. Next Saturday, June 27 at noon, SSSSS